So this is part 2, and from the previous video clip we were estimating implied volatility, which we've done using a bisection function. We estimated an OLS regression using this expression of implied volatility is equal to constant plus the coefficient A1 on x all the way out to A5 by the product of the exercise and the time period. Now probably it makes more sense to write this as x. It's consistent with the exercise. If we look at the motivation for this specification, we go to Dumas-Fleming-Whaley, and it's equation 9 that sets out the relationship between implied volatility and the exercise squared, the maturity squared, and the product of the exercise by time. So this is a quadratic type relationship that we're following. We're estimating it here. We've regressed using the Linest estimation. Implied volatility is the dependent variable, and x squared, maturity squared, and the exercise by the maturity are the independent variables. And in the estimation we've included a constant as well, so we get that A0 value here. From those coefficients, then from the quadratic, if you like, if we specify this as the quadratic relationship or the deterministic volatility function, we try to get a fitted implied volatility, and that involves estimating, taking the coefficients and multiplying them respectively with these values here. And that, if we go to the next cell, you can see that's done in a sequential fashion. We go again, same parameters used and multiplied. A0 by x, A0 is the constant, A1 by x, A2 by x squared, A3 by the time period and maturity, A4 by the maturity squared, and A5 by the product of the exercise by the maturity. Okay, so we drag that down, and if you like, that's one of the outputs we would like to generate. Okay, now if we go back to the Volupta files, right, we have that project set up in C++. I would like to replicate that exercise using the quadratic volatility function. I've already have the files, the Volupta files here, the source files, the data file, and the header files, and I would like to put them together as a project. So first thing we will do is we'll open up Visual Studio, and actually we can just open up like this. And okay, so our file, okay, so it's an ad hoc Black-Scholes model, also called Practitioner Black-Scholes model. Some other people involved in this area, Christofferson, Chris Jacobs, in their 2002 paper, they also refer to a Practitioner Black-Scholes model, which involves estimating an implied volatility, then linking it back to a quadratic relationship, and then using this quadratic as an interpolation tool to estimate any given option with a particular exercise and maturity. So okay, so we have this file open. Now let's incorporate it into a project. So I'll copy and paste the file. Okay, we'll just copy, and okay, the basic elements of the file are that there's a number of libraries that it's calling in. There is a spot risk-free rate, dividend yield, and it also is pulling in data from the Dow Jones Industrial Average text file, and that data then is used to output estimate the quadratic, used then to estimate the relevant implied volatility and output a variety of actual implied volatility and fitted implied volatility, market price of the option relative to the price generated from the model itself. Okay, so in the first step to link this project, we'll say File, New Project. We can give this any particular name you want. Okay, so we have, we can call it Volupta Implied Volatility. I'll say Dow Jones Industrial Average. Okay, and Volupta Implied Volatility, yeah. And then next, and empty project, which is important. And we add a source file. And we'll try to be consistent with the file that we have here. So it's Dow Jones, Black-Scholes Implied Volatility. Let's get the full name here. Black-Scholes Implied Volatility and Dow Jones Industrial Average Option Prices. Okay, so I've written that in, and that's consistent with the name of the file here, and we'll add. And now when we open up the file, there's nothing there, but I can paste the code that I copied previously, and it's gone in. Are there any issues? There's a couple. One that I can easily resolve, just do 2 forward slashes. In the case of the Black-Scholes H and matrix operations, I have to include in these header files, so they'll resolve themselves. Okay, so in addition, then we have more files to put in. Let's take a look what's here. Okay, we have Black-Scholes CP, so let's open that file. Let's copy it. Copy, paste. I'll close that file down. I'll add a new source file, add new item, and we'll write in the name. Okay, so we add that CPP file in with the name Black-Scholes, and it's an empty file. We have to paste in what we had copied previously. And a couple of issues. One we can easily resolve, just 2 double forward slashes. That neutralizes that line of text, that line of code. And we have to be careful that it's the Black-Scholes is written exactly as is here. So we have Black-Scholes as well here. Okay, next in turn then is we have to put in another CCP file, so the matrix operations. So let's just double click. We'll open up. We'll copy. Now the matrix files are necessary to run the OLS, and they're interesting in their own right, but I'm not going to use today. So let's just close this one down and go add new item, and then it's a C++ file, and it's going to be called matrix operations. Okay, so matrix operations. Okay, and I have to use exactly the same names in each instance. So we'll add, and we'll paste in the relevant code, and again, these are matrix operations for getting the inverse of a matrix, getting the transpose, getting multiplying two matrices together, and this is what's going to be used for running an OLS regression estimation. Okay, so in addition then we need to put in header files, add, and we'll have to put in a new header file. And what header files are we going to use in this case? The header file, well, we have a matrix we can start up here, blackscholes.h. Okay, so the matrix file is blackscholes, and it's a header file, so just add, and we leave that pragma there. So let's get the file in question. And we'll copy. Okay, so copy pragma, copy, go back into blackscholes H, and well, we can take it out because pragma is there in the snippet that I've included. Okay, so pragma.h, and in addition we've one more H file. We have a header file, matrix operations. So we've H here and H here. Let's just open it up. Let's copy that file, copy, and we can close it down, and we'll add new item. It's a header file, and again, just to be clear, the name of the file is matrix operations. Okay, so we put that in, matrix operations. We should have everything the same, matrix operations. Add, it's an empty project, so let's just paste in, and we have our functions. And now the last function we need to set up is the resource file. Okay, so let's see, do we have any red here? Is there any issues? No, the red underline, the scribbles that appeared in the originals seem to have been taken care of. Right, so no outstanding. Oh, okay, let's have a look here. And again, we can just neutralize this problem by double /, and then on the header files, everything seems to be fine. Everything seems to be fine. So before we add in the resource file, we debug just to see if the file is executing, but nothing will happen in reality in terms of estimation because we haven't included in any data. Okay, so we just get a blank debug window coming up, and there are no apparent errors. Okay, now to add in the resource file, I go back to the zipped folder, and I'll copy that file, and then I go to Documents and to Visual Studio 2017 Projects, and I'll go down to the latest project, so Velopta, and then in this file folder here, paste in the data, and then I say come back to the resource file, add existing item, and link to the Documents Visual Studio Projects file I'm working on, and link through and add, and then I run the project to see if it's working. The project's executed, but I should put in a pause command. So let's go to here where the cout function is, cout, and just here at the end I'll put in a system pause. Okay, so I've put in system pause, and I'll run, and this debug window comes up. So I have a strike, maturity, implied volatility, fitted volatility, market price, and model price. Okay, so I can, in the next video, I'll copy and paste this material into the Excel spreadsheet just to compare.